In this question, we are looking at friction and sloping or inclined planes. And you should give yourself a reminder about resolving forces parallel and perpendicular to the sloping plane. And the three forces generally here are weight as an mg, your normal contact reaction as an r, and friction. So I'm just highlighting things here. So mu is 0.36, and the other details there we'll come to in a second. So always start with your diagram, whether you've been given one or not. So I've just underlined or highlighted, these aspects for the mass, the incline, and so on. So straight down, of course, is our weight, 0.6 g. We have the contact force, r, and then we'll create our little sine, cosine components there. And of course 25 is the angle there, just inside the particle, parallel to a line of greatest slope. Okay, just to start off, r is in line with cosine there, so 0.6 g cosine 25. That'll come in handy in a second when we're finding our friction. So F is equal to mu r. We'll do that in a moment. So resolving, or for resolving in this case, it's just my convention. Going up, so sliding up, so P is equal to F plus 0.6 g, and it would be the sine component, so sine 25. Okay, so we're looking to see what possible values we can get here. So we're going up and down the plane basically. So going down, P is equal to minus F, and the same other details. So we're trying to find basically a maximum and minimum for possible values of what P would be. And our friction is F equals mu r. Friction is very much a part of this. And you might need to take some time to look over how the real life aspect of this works with sliding up and down in terms of limiting equilibrium. So mu r is there already, we have these details. So resolving perpendicular is often the right way with the normal reaction force to find that magnitude. And we're finding, again, you have a set of possible values. So that's, as far as I'm concerned, it's kind of a max and min. So P max and P min. Again, a lot of this is putting these forces together. So based on our first equations, so mu r, which is positive, sliding up, plus of course the sine component, and our minimum will be negative minus mu r plus that same sine component. You can put the minus outside the bracket if you want. And it's the same thing there basically. And you can get your calculator out and put this all together. So 0.36 times 0.6 g cosine 25 plus 0.6 g sine 25 is 4.49, and with a negative value in our first part there, we've a much smaller answer, 0.578. That's our max and min, and they are the set of possible values for P. So just remember the setup of this question is the most important thing. You may have a change in direction, you may have certain aspects that will happen. Just keep an eye out on the different aspects of where your particle is moving and what's happening. I'll do a follow-up video on the change of direction because that takes a little bit more thinking. And there's our answer. 0.58 is less than or equal to P is less than or equal to 4.49.